In this question, we're told that CDEF is a quadrilateral. The vector CD is equal to A, the vector DE is equal to B, and the vector FC is equal to A minus B. And in part A, we need to express the vector FE in terms of A and or B, giving our answer in its simplest form. Now let's mark the vector FE on our diagram. Now the blue line shows how we can get from F to E. But just using that blue line, we can't express the vector FE in terms of A or B. So let's see if we can figure out an alternative route to get from F to E. Well, to get from F to E, we can start by going from F to C. Then we can go from C to D. And finally, we can go from D to E. Well, now we have enough information to express the vector FE in terms of A and or B. We know that the vector FE is equal to FC plus CD plus DE. Now, using the information given to us in the question, we can say that the vector FE is equal to A minus B, because FC is equal to A minus B, plus A, because the vector CD is equal to A, and plus B, because the vector DE is equal to B. Now let's simplify this by collecting like terms. We have A plus A, which is equal to 2A, and then we have minus B plus B, which is equal to 0, leaving us with a simplified vector of 2A. And so we've found that the vector FE is equal to 2A in its simplest form. Now we're told that M is the midpoint of DE, and X is the point on the line FM, such that the ratio Fx to Xm is equal to n to 1. We're also told that CXE is a straight line. And in part B, we need to work out the value of n. Let's start by finding the value of the vector Fm. And we can use our diagram to help us. So to get from F to M, we can start by going from F to C. Then we can go from C to D. And then we can go from D to M. Now, since we're told that M is the midpoint of DE, the vector DM would be half of the vector DE. We know that the vector DE is equal to B, and so the vector DM must be equal to half B. And so we can say that the vector FM is equal to FC plus CD plus DM, which is equal to A minus B plus A plus half B. And we can simplify this by collecting like terms. A plus A is equal to 2A, and minus B plus half B is minus half B, and so the vector Fm is equal to 2A minus half B. Now let's see what this means in terms of our ratio, and we can use a diagram to help us. Well, we have the line Fm in front of us, and X lies on this point, such that the ratio Fx to Xm is equal to n to 1. Now, using this ratio, we can say that there are a total of n plus 1 parts. And so we know that Fx has n of these parts, and Xm has 1 of these parts. Now, given that the total value, Fm, is equal to 2A minus half B, and Fx has n of these parts, we can say that the value of Fx is n over n plus 1, multiplied by the total of 2A minus half B. And so applying the same principle to Xm, we know that Xm has 1 over n plus 1 parts. And so we can say that the value of the vector Xm is 1 over n plus 1, multiplied by the total of 2A minus half B. Well, now we're also told that CXE is a straight line. And so because CXE is a straight line, we can say that the vector CX is parallel to the vector CE. That might not seem important right now, but we'll need that information later. Now let's take a look at the vector CX. Now, to get from C to X, we can start by going from C to F. And then we can go from F to X. And so we can say that the vector CX is equal to CF plus the vector FX. We're told that FC is equal to A minus B, and so CF would be the negative of this. And so CF is equal to minus brackets A minus B. Now we need to add Fx, and we said that the vector Fx is equal to n over n minus 1 multiplied by 2A minus half B, which we can now add on to our vector Cx. Well, now we have a lot of simplifying to do. Let's start by expanding the first set of brackets, and so minus brackets a minus b, we can imagine that this minus sign is equal to minus 1. And so minus 1 multiplied by a would be equal to minus a, and minus 1 multiplied by minus b would be equal to positive b. And so the first set of brackets simplifies into minus a plus b. Then we need to expand the second set of brackets, and we have n over n plus 1 multiplied by 2a minus half b. Well, first of all, 2a multiplied by n over n plus 1 would become 2n over n plus 1 a. And minus half b multiplied by n over n plus 1 would become minus 1 over 2 lots of n plus 1 b. Now you'll notice that we have some circles in blue and some circles in orange. And what we're doing here is collecting like terms, because we want to group the a's together and the b's together. We'll start with the blue circles. Well, minus a plus 2n over n plus 1 a can become minus 1 plus 2n over n plus 1, all multiplied by a. Now looking at the orange circles, b minus n over 2 lots of n plus 1 b can be simplified into 1 minus n over 2 lots of n plus 1, all multiplied by b. Now we need to add these fractions, and when we add fractions, remember that we need a common denominator. Now let's first start by looking at the terms of a. We need to do minus 1 plus 2n over n plus 1. We need to express minus 1 with a denominator of n plus 1. And so minus 1 can be written as minus brackets n plus 1 all over n plus 1. And so we can say that minus 1 plus 2n over n plus 1 can be written as minus brackets n plus 1, close brackets, plus 2n all over n plus 1. Now let's do the same thing for the terms for b. We have 1 minus n over 2 lots of n plus 1. Now to make these have a common denominator, we need to express the number 1 so that it has a denominator of 2 brackets n plus 1. And so we can just say that 1 is equal to 2 brackets n plus 1 divided by 2 brackets n plus 1. And so we can write 1 minus n over 2 lots of n plus 1 as 2 lots of n plus 1 minus n all divided by 2 lots of n plus 1. Well, now let's expand these brackets. Minus brackets n plus 1 becomes minus n minus 1, and then don't forget the 2n, all over n plus 1. And now to expand the second set of brackets, we have 2 multiplied by n plus 1, which becomes 2n plus 2, and then the minus n, all divided by 2 lots of n plus 1. Now we can simplify this even more. Minus n minus 1 plus 2n can be written as n minus 1, and so the vector cx is equal to n minus 1 over n plus 1 a. Now looking at the terms for b, 2n plus 2 minus n is the same as n plus 2, and so the terms for b becomes n plus 2 divided by 2 lots of n plus 1 b. Now earlier we said that CXE is a straight line, and so CX is parallel to CE. And so because they're parallel, we can say that the vector CX is a multiple of the vector CE. Now looking at our diagram, we can say that the vector CE is equal to CD plus DE, which is equal to A plus B. CE is equal to A plus B, and so it's really important to note that the coefficient of A is equal to the coefficient of B. And so we need to pick up on the fact that because CX is parallel to CE, the same principle applies to CX. And so for the vector CX, the coefficient of A must be equal to the coefficient of B. Now we know that the vector Cx is equal to n minus 1 over n plus 1 a plus n plus 2 over 2 lots of n plus 1 b. We said that for the vector Cx, the coefficient of a is equal to the coefficient of b, and so we can say that n minus 1 over n plus 1 is equal to n plus 2 over 2 lots of n plus 1. Now we can begin to simplify to solve for n. Now we have n plus 1 in both denominators, and so these cancel out. And so we're left with n minus 1 is equal to n plus 2 over 2. Now we can multiply both the left hand side and the right hand side by 2. And so we can say that 2 lots of n minus 1 is equal to n plus 2. Expanding these brackets, we can say that 2n minus 2 is equal to n plus 2, and we can move the n over to the left hand side by taking away n from both sides, leaving us with n minus 2 is equal to 2. We can move the minus 2 from the left hand side to the right hand side by adding 2 to each side, and so we're left with n is equal to 4. And so we've now completed part B and found that n is equal to 4. Now this question is worth 6 marks. We get the first mark in part A for saying that the vector FE is equal to A minus B plus A plus B. And we get the second mark for simplifying this vector and for saying that the vector FE is equal to 2A in its simplest form. We get the third mark in part B for a process to find the vector Fm and for saying that the vector Fm is equal to 2A minus half B. We get the fourth mark for a process to find the vector Cx. We get the fifth mark for saying that n minus 1 over n plus 1 is equal to n plus 2 over 2 lots of n plus 1. And finally, we get the sixth mark for rearranging and simplifying and for saying that n is equal to 4, allowing us to achieve the full 6 marks needed in this question.